Welcome back. Today we're going to work a little more with factoring, and today we're going to factor by grouping. Within these factor by grouping problems, we're going to see now more than just those four terms, or maybe more than five terms possibly even. We're also going to see some factoring with some quantities and some of those bigger perfect square problems. So let's go ahead and get started with an example. Remember, when we were factoring four terms, we always broke it up into 2 and 2. So we always looked at those first two terms, and then we decided what could we take out. And we took out the second two terms. Or what we did was we tried to rearrange them so we could get those same quantities. Same kind of thing's going to happen with these problems. But now we're going to have to kind of break it into maybe a group of 3 and a group of 2. We may even have to do a group of 4 and leave that one out there by itself and kind of work with it. So a lot of this is going to be guessing and checking, and it's going to be kind of playing around with what we have and what we can see. So a couple of things that I like to look for as I'm doing these. One, if we look at x squared and we have a y squared in here, and we have this 5xy. If I look at this term, these three terms together, that's factorable. I can factor that to x plus 3y and x plus 2y. Again, recall we can take x times x gives us our x squared. We have 3xy and 2xy added together gives us our 5xy. And then 3y and 2y multiplied together gives us 6y squared. And 3x plus 9y, I can factor a 3 out of those. So I get x plus 3y. Now notice I have two terms. I had 5 terms up here. Now I have 2 terms. Remember, I separate with a plus or minus sign. Everything else is being multiplied together. But I have these 2 terms in common. So I can write this as x plus 3y, and then times my leftovers. My leftovers would be x plus 2y, plus my leftover here, which is 3. And that's going to be our nice factored form of this quantity up here. Our next example, we're going to see very similar to that. Notice we have our x squared and our y squared. We have an xy in the middle. So I can go ahead and try to factor that for us. Let's see, we get 3x. We're going to have an x. Recall this negative 2. That negative 2y can go here or here. But when I add these together, I get that negative 5xy. So I'm going to try my negative 2y here and a positive 1y there. Now, see if it works. Here I get negative 6xy and a positive 1xy. Negative 6 plus 1 gives me that negative 5, doesn't it? On my last two terms, I can factor out a negative 4, and I'm left with an x minus 2y as well. So now here, notice I've got the x minus 2y in common, so I can pull that out as my GCF, and what I have left over is a 3x plus y minus 4 from my second quantity. And that would be my factored form. In example 3 here we're getting into those factoring with quantities. So think about x squared minus 16 squared minus x plus 4 squared. Well, x squared minus 16, that should ring a bell to us. That's factorable. So we can write that as x minus 4, x plus 4. But remembering that's all being squared, isn't it? Alright, so we have x minus 4 times x plus 4 squared minus x plus 4 squared. Now what I can do is take that squared, and I can distribute it into each of these quantities, since it's being multiplied together. So I get x minus 4 squared times x plus 4 squared minus the quantity of x plus 4 squared. If I look at my common terms, I have x plus 4 in common. So I get x plus 4 squared times x minus 4 squared minus 1. And x minus 4 squared minus 1. Oh, well, think about that. That's a difference of squares as well. So I get x plus 4 squared times x minus 4 minus 1 and x minus 4 plus 1. So you think about this term in here. Think about x minus 4 squared if I let it be y. If I let y equal x minus 4, then y squared would be x minus 4 squared, wouldn't it? So if I replace that x minus 4 squared with y, I would end up with y squared minus 1. And y squared minus 1 factors the y minus 1, y plus 1. Recalling that y was x minus 4, so I get x minus 4 minus 1 and x minus 4 plus 1, which is where I got these two terms here. So my final answer is going to be x plus 4 squared times x minus 5 and x minus 3. Again, not the only way you could do this problem. There's several ways you could attack it. You could have gone up here and you could have squared it all out, cleaned it up, combined like terms, possibly get it factored that way. Another thing that you could possibly see would be a difference of squares up here as well. You could see this as x squared minus 16, that's a perfect square, and x plus 4 is a perfect square. So you could factor that as well. So a couple of different ways you could think about it. This one I kind of liked myself personally. In example 4, we're back to this 5 terms. So what do we notice about this 5 term? Well, notice my a squared and my ab's are way away from that b squared, isn't it? But I can always move that 3b squared to in front of this negative 3a. And I like that because I have an idea that that's going to factor for me. I also noticed as I was writing that, I also noticed that each of these terms are divisible by 3. So I can factor that 3 out of everything to make my life a little easier, a little smaller, if you want, of the terms that we're going to work with. Go ahead and clean those up. So a squared minus 2ab plus b squared, that factors the a minus b and a minus b. If you want it would be a minus b squared. If I pull out a negative out of these, I get a minus b as well. So I can go ahead and factor. I can factor out an a minus b, and I'm left with a minus b here, minus a 1 when I factor a minus b out of that. So that's going to be my factored form. Again, you can always check these. If you were to distribute all this back out, you should come up with the same answer that we had up here. Next example here, we have a to the third plus a squared plus b to the third minus b squared. So think about this one. We have 4 terms. So if I think about the first 2, can I factor something out? I sure could. And the b's I can factor out. See if it gives us anything. So we have a squared times a plus 1 plus b squared times b minus 1. Remember, to be able to factor by grouping, we have to be able to take out a quantity that's the same. So even though this is first step factorable, we're not going to get anything that's going to yield us anywhere that we can, anything that we can do any good with. So we get rid of that. We have to rearrange this. What could we arrange? Well, what about a to the third plus b to the third? And putting a squared minus b squared together. Do I know what a to the third plus b to the third factors to? I sure hope so. We get a plus b times a squared minus ab plus b squared. And a squared minus b squared, that factors to a minus b, a plus b, doesn't it? Now notice I have an a plus b in common. So I have a plus b times, now I can go ahead and pull these together and I get a squared minus ab plus b squared plus my leftovers over here, which are my a minus my b. And that would be our factored form of that. I think I have just one more, and that's going to be our factoring big perfect squares. I call them big perfect squares. So when these exponents are very large, can we factor them? So x to the 16th minus y to the 16th, can we factor that? And I hope we can. Remember, that they are perfect squares. They're both divisible by 2, aren't they? So they're going to be perfect squares. So we get x to the 8th minus y to the 8th, and x to the 8th plus y to the 8th. I can go and factor x to the 8th minus y to the 8th. That's x to the 4th minus y to the 4th, and x to the 4th plus y to the 4th. Recalling that the perfect squares, the sum of perfect squares does not factor. So we're going to leave it as x to the 8th plus y to the 8th. Coming back here, x to the 4th minus y to the 4th, that's going to factor. We get x squared minus y squared times x squared plus y squared. And we can bring these down, x to the 4th plus y to the 4th, and x to the 8th plus y to the 8th. Again, sum of squares is not factorable for us. And if we have x squared minus y squared, that's going to factor x minus y, x plus y, x squared plus y squared, x to the 4th plus y to the 4th, and x to the 8th plus y to the 8th. Again, recalling, perfect squares do not factor when they're being added together. So that gives you an idea of some more complicated factoring, some factoring by grouping. We had to rearrange some of the terms to be able to get it in a form that we can find the factors of. So I'm sure that you'll have lots of questions, so don't hesitate to reach out. Give me an email and we'll get through these problems. Good luck, enjoy, happy factoring.